program here is going to have a really useful application for a loop for something mathematical. You may have encountered factorial in mathematics, but it's pretty much like this. So we write a factorial. So imagine I wanted to find 3 factorial, and I would be usually using this in some sort of calculation to find out how many ways I can combine different items and different sort of orientations. So if I was using this, I would do 3 times 2 times 1. So this is what factorial means. So I would get the result 6. Now, if I wanted 4 factorial, I would get 4 times 3 times 2 times 1, which is going to be equal to 24. So the general case that we're going to use for this is if we have some number factorial, it's always going to be equal to n times n minus 1 times a bunch of other numbers, and then we're eventually going to get down to the number 1 every single time. So this is what we can use to help plan this out. So in this scenario, what we're going to do is we're going to have a number. So let's make n equal to 5. We'll start with 5 just because it's 1 beyond 4, and then it's like starting to get a little bit tedious to do the calculation. And then we're going to have a result value. And this is going to be our accumulator. So this is our accumulator for this example. And accumulators we typically initialize as 0. So what we're going to do is we're going to first display what our problem is. So we're going to put n factorial. And then we'll put an end L here. And then we're going to write our loop. So potentially, I guess the loop could be so small that we wouldn't run it. So I will start this as a while loop. So while n is larger than or equal to 1, what we're going to do is we will first, so if we get in with 5, and result is going to be our accumulator that will eventually collect the answer. So what we're going to do is result is going to be result times n. So this is, we're going to be multiplying to get the answer instead of doing a typical addition. And then, so this is, say, imagine it's 4 factorial, this would give us our 4, and then we're going to multiply a 3, and then 2, and then 1. So every time we go through the loop, n is going to have to reduce by 1. So we're going to put n minus minus to decrement the n value. And then we're going to display our result at the end. So cout result. And then we'll put an end L. And we'll just, for clarification, in the output, let's put the word result here so that we can see what we get. Okay, so we've got 5 factorial, and let's see what we get as the solution. So I'm going to run this, and there's an issue here. It says 5 factorial and the result is 0. Well, we know that 5 times 4 times 3 times 2 times 1 would not be 0. So we have to take a look at the problem here and figure out how that happened. So what's happened, and this is why I used this example, is there's an error in the code. So if you want to challenge yourself, you could pause the video now and try and figure out what the error is, and then we'll move ahead in just a second. So what happened here is our accumulator ended up having a result of 0. So typically we assign an initial value for our accumulators to be 0. However, this is causing us a problem in this scenario. So imagine we have 0. I'm going to trace the values through here, which is a really great problem-solving technique, and hopefully you use this to try and find out what the mistake was. So we've got, well, n is greater than or equal to 1. Result equals result times n. So the first time we go through the loop, n is 5. So the result equals, wait a second, 0 times 5. And then the next time it goes 0 times 4 and then 0 times 3. Because result starts at 0, it actually doesn't hold on to the value. So when we're using an accumulator that multiplies the value instead of adds the value, we always set our accumulator to 1 as the initial value. So this is pretty important, and it will come up in potentially some other exercises where we are multiplying the values of our accumulator instead of adding them each iteration of the loop.